Hello everyone. Let's start with this another question of the Kaplan kit. It is a section B question, and the question is: Gadget Company. Gadget Company produces three products A, B, and C, um, all made from some same material. Until now, it has used traditional absorption costing to allocate overheads to its products, and the company is now considering an activity based costing system in the hope that it will improve profitability. Information for the three products for the last year as follows. The production and the sales volume for A, B, and C are given as follows, and selling price per unit has been given, raw material cost per unit has been given for A, B, and C. Direct labor R per unit has been given, machine R per unit has also been given, number of production runs per annum, number of purchase orders per annum, and number of deliveries to retailers per annum. So the direct labor cost for the whole workforce was 14.80 per hour. The annual overhead cost were as follows: machine setup cost 26,550, machine running cost is 66,400, procurement cost is 48,000, and delivery cost is 54,320. Now let's read the first part of the question. The first part of the question is: which of the following statements are true for Gadget Company? Under traditional absorption costing and using production volumes as a basis of apportionment, the overhead absorption rate is 4.34 per unit. If I have to start with question number one of this Gadget Company, and the very first part of this is asking us that whether we need to assess is it true or false if under traditional absorption costing using production volumes as basis of apportionment, the overhead absorption rate is 4.34 per unit. So the total overheads should be 26,550 plus 66,400 plus 48,000 plus 54,320. Okay, so these the so as per by after totaling, my cost comes out to be 195,270. These are the total overhead costs. These are the total overheads cost. If this is my total overheads cost, now it is asking me in the first part that indirectly, now I'll to evaluate whether this first statement is correct or not, whatever I have to do is I'll have to divide the total overheads by the volume. So what is the volume? The volume, sales volume has been given like 15,000 for A, 12,000 for B, 18,000 for C. So the total volume over here is 15,000 plus 12,000 plus 18,000, that is 45,000. So the overhead rate is 195,270 divided by 45,000, and it will give us 4.339. So this is 4.34. So the statement 1 is correct. Now let's talk about the statement 2. Under activity based costing, product C will have 2.07 of machine running cost. 2.7 of machine running cost. We have not been given the number of runs in this question. We have been given the number of production runs. So we need to be very careful. It is not asking about the production runs, but it is asking about the machine running. So it can be confusing, wherein lots of students they can take production runs as the basis of calculating the absorption overhead rate for the machine running cost, but this is not correct. So the machine running cost over here is 66,000 400, and this will be divided by sorry, and this should be divided by the number of machine hours. So how many machine hours can we calculate? Now I will solve this over here because it would require some space. First of all, let me mention this is the machine running cost. Machine running cost is 66,400. The number of okay, so the machine hour per unit is also given. Machine hour per unit for A, B and C, these are 0.5, 0.7 and 0.9. So units, because I need to calculate the total machine hours. Again, I am repeating, please do not get confused with the production runs and machine runs. Okay, production runs and machine running machine runs are totally different. Machine runnings can be dependent on the machine hours and not on the production runs. So the units which have been given to us are 15,000, 12,000, 18,000. Okay, sorry, this had to be written a little upwards. 15,000, 12,000 and 18,000, and over here I can calculate 15,000 into 0.5, this is 7,500. 12,000 into 0.7, this is 8,400. 18,000 into 0.9 is 16,200. So total I will get 7,500 plus 8,400. The total hours are 3,100. So my overhead absorption rate of machine running cost is 6,400 divided by 3,2,100, and I will get 2.06. Yeah, so it's 2.068. I can say that this is 2.07. So my second statement is also correct, and I can say that both 1 and 2 are wait a minute. So under activity based costing, okay, now what mistake I did over here is we need to see it very carefully. What I calculated it is the overhead absorption rate. This is the overhead absorption rate, and over here the statement is for product C. It would have been 2.07. So this is not for product C. This is the overhead absorption rate for product C. Now for product C, the situation will be different. The machine hours for product C are not 2.07. It should be 2.07 multiplied by the machine hours per unit, or the machine hours. So for product C, the machine running cost is 2.07 into 16,200, which is 16,200 into 2.07, 33,534, and so the machine running cost per unit for product C should be 33,534 divided by how many units are there? 18,000. So this is 1.863. So the statement 2 is incorrect. See, this is how we can make the questions are quite tempting, and then we can make a lot of careless mistake. 2.07 is not the over here I have calculated 2.07 is not the machine running cost per unit for product C. It is the overhead absorption rate for the machine running cost for all the products A, B and C. And if we need to calculate the machine running cost per unit for product C, what will I do? I will multiply 2.07 into the total machine hours which have been taken by for product C, and then I will divide the entire machine running cost of product C. This is for product C. And then I will divide the entire machine running cost of product C by the number of units produced for product C, that is 18,000, and this is how I will get a machine running cost per unit of product C. So these the answer is only only B. Now what is the full cost per unit of product A under traditional absorption costing using direct labor overheads as the basis of apportionment? So the total overheads which I calculated was 195270. The total overheads which I calculated over here was 195270. It is asking us to absorb these overheads on the basis of traditional absorption costing using direct labor hours. Now in the question we have been given direct labor hours per unit as 0.1, 0.15 and 0.20 per unit. So direct labor hour per unit is 0.1, 0.15 and 0.2, and number of units is 15,000 for product A, for product B it's 12,000, and for product C it's 18,000. So labor hours would be how much? 15,000 into 0.1, 1500, 12,000 into 0.15, 1800, 18,000 into 0.2, 3,600. So the total labor hours would be 6,900. So the total labor hours are 6,900, and now I will calculate the overhead absorption rate based on the traditional absorption costing method, which is 195270 divided by 6,900, and I would get 195270 and I would get 69 divided by 69. This is 28.3. Now this is my overhead absorption rate. If I need to calculate the full cost for product A, then first I will find out the prime cost. What is the prime cost? The prime cost would be raw material cost. So the raw material is 2.4 per unit. So I will do 2.4 into 15,000, which is 36,000. After that I have direct labor, and direct labor was 0.1 per unit. but these are hours. This is there is no labor cost available. So how will I calculate? Is it given in the question? Let's read it out once again. Yes. So the direct labor overhead cost for the whole workforce was 14.8 per hour. So how many hours product A requires? It's 0.5 per unit. Okay, if one unit takes 0.5 hour, then 0.5 hour. Okay, so this is not 0.5, sorry, it's 0.1. So the labor hours which have been taken by so the direct labor cost is 0.1 and it is 14.8 is the absorption rate, so it is 0.1. So and we have to multiply this by units as well, because 0.1 is taken by for per unit. 0.1 labor hour is required for 1 unit. So for 15,000 it will be 1500 hours, and per hour cost is 14.8. so 1500 would be multiplied by 14.8 and I would get 22200. So this is my prime cost. Now it is the overhead cost. The overhead cost I have calculated as 28.3, and this is 28.3 per labor hour. Okay, so how many labor hours are required? The labor hours required for product A is 1500. So 28.3 into 1500, it is 42,450, and so the total cost is 58,200. That is 10650. Now this is the entire cost, but if I have to calculate the per unit cost, full cost per unit will be 10650 divided by 15,000, because we are calculated for product A. So it will be 6.71. all right. So we are done with the second part as well. Which part we have done with? We are done with the second part. Now it is asking calculate the overhead cost per unit for product B using activity based costing. We just have to calculate the overhead cost. Third part, overhead cost based on ABC costing method. So these are the various cost pools which have been given: machine setup cost, machine running cost, procurement cost, and delivery cost. First we will write up the cost pools. So the first cost pool is machine setup cost, and we are calculating this thing for product B. So for product B, the machine setup cost, the entire machine setup cost is 26,550. But if the machine setup cost is 26,550, what will be the driver of this cost? The cost driver for this machine setup cost should be number of setups done. But are they given? Is this information given within the question? No, this information is not given within the question. So what will I do? Now machine setup cost can be either. First you will think about, can I assume that that for machine setup cost, the cost driver can be machine running cost, machine hour cost, machine hours, sorry. But for machine hours is required for machine running. Okay, the number of hours taken by a machine to run itself, and which is really different from the setups. So how many times the machine would be setups? It will be set up based on the number of production runs. Because for example, if we have this machine A, okay, and we need to produce 15 units, and during one run only one unit is produced. So by production run, what do I mean? That I will have to set up the machine for each run, and after that I would switch it off or dismantle it, right? So for each run I will have to calculate the machine setup cost for based on the number of production runs. So the machine setup cost is 26550, and the production runs per annum are 16, 12 plus 8. This can be quite confusing, because even I was confused when I saw that okay, machine setup cost is given but there are no number of setups given. But then if there are no number of setups given, the number of setups will be dependent on what? Either they will be dependent on machine hours. The very first thought came in my mind was that it can be dependent on the machine hours, or it can be dependent on the production runs. So obviously I will set up the machine for the production runs required. I will not set up the machine based on the hours which have been taken for the machines while for the hours while they are being run. So 26550 divided by 36, and I get the overhead absorption rate for this is 737.5. Next cost pool is machine running cost. Okay, first was machine setup cost and now it is machine running. Now this should not be confusing. The machine running cost was 66,400. We had calculated this based on the machine hours. Okay, I'm double underlining this. And after that, which cost pool we have? We have procurement cost. What is the cost driver for procurement cost? The cost driver for procurement cost can be the number of purchase order. So the number of purchase order is the cost driver for it. After procurement cost, the next cost driver is the delivery cost. And we have no doubt that it is very simple. It will be dependent on the number of deliveries, which has already been given in the question. Everything has been calculated. Now let's calculate the overhead cost for product B. The first was machine setup cost. And this is 737.5. And how many setups are there? There are 16 setups. So 737.5 into 16, which is 11800. I think I've made a mistake over here. We are calculating this for product B. So for product B, the number of setups were 12, not 16. I took it for product A by mistake. 737.5 into 12, it is 8850. The machine setup cost, after that machine running cost, I have 2.07. Again, this was absorbed on the basis of production runs. Was this absorbed on based on what? This was absorbed on the basis of hours. How many hours? So I think I had already calculated this. I think B took 1800 hours. So I should multiply it by 1800. Again, I have made a very careless mistake. So this was, sorry, I took 1800 from here. 1800 from here, but this was labor hours. We need machine hours. So I had calculated over here for product B, which is 8400. 8400. We need to be very careful of these things. After that, this is procurement cost. And the procurement cost is 510.60 into number of procurements for product B. And the number of procurements for product B is 28. After procurement cost, we have delivery cost. And number of deliveries is 30. Now we can have total overheads cost for product B by adding all of them. and the per unit cost of overhead for product B is how many units product B produced was 12,000, right? This is 4.34 or 35 we can say, because it's 4.348, and so the answer is C over here. Now let's jump on to these multiple choice question. The very first question it's saying is the full cost per unit of product C is 13.42 under traditional absorption costing and using labor hours as the basis, and 12.48 under ABC. So it has already given that for product C, the absorption rate, the traditional absorption rate for product C is 13.42 for overheads, and for based on the ABC costing method, the overhead absorption rate is 12.48. So which of the following statements about product C are true? Product C should not produce as it makes a loss per unit. Second part is one of the reason for a cheaper unit cost under ABC is the lower number of production runs needed for product C. Lower number of production runs for product C. If there are lower number of production runs, okay, I understood. So in statement 2, what I can say is that the number of production runs in case of product C is 8. Okay, so while calculating the overheads for product C, I would multiply the overhead absorption rate for production runs. And what was the overhead absorption rate for production run? We had just calculated for product B only. I think it was based on the machine hours, and it was 2.068. So if I will multiply that with the number of runs, right? How many runs are there? Production runs, that is 8. So obviously it will give me a lower cost as compared to the other products. Let us read again because it can be confusing. So the very first statement was product C should not be produced as it makes a loss per unit. It is not making loss per unit. I really don't understand how can it make loss per unit, because if the overhead absorption rate as per the traditional costing method is 13.42, and as per the ABC costing the overhead absorption rate is 13. So how did it these both are not related to each other at all. There is no selling price also given. Yeah, the selling price is given. It is 7. No, not 7. For product C, the selling price is 13. Yeah. So the selling price for product C is 13. And if I reduce the cost which has been given to me, the full cost per unit is 13. Okay, 13 minus 13.42, as per the traditional cost method. So if I subtract 13 from 13.42, I would get a loss of 4.42, right? How I did this is, as per the traditional absorption costing, the full cost is 13.42. Now the selling price of product C is 13, and as per the traditional overhead absorption rate, the cost comes out to be 13.42 per unit. So the loss is 0.42 as per the traditional absorption method. Traditional, I'm writing over here as traditional. Now as per ABC, the selling price is 13, and as per ABC, the overhead absorption rate is 12.48. Over here, I'm not having any loss. So 13 minus 12.48, it will give me 5.52. Now the statement 1 says product C should not be produced as it makes a loss per unit. This is incorrect because, okay, it is making loss as per the traditional absorption costing method, but it is not making any loss as per the ABC costing method. So if product C is being produced by using ABC costing method, then it can make profit. Now let's jump on to second question. It is a second part. It is saying one of the reason for cheaper unit cost for ABC is lower number of production runs needed for production C. First of all, I need to see if the production run was 16, 12 and 8 for A, B and C. Where did I use production run as cost driver? For which cost pool did I use production run as cost driver to calculate the overhead absorption rate based on the ABC costing? So I had solved over here this question. So I had used this for machine setup cost. So it ideally, as per this statement 2, the machine setup cost would be lower for product C because the number of production runs are comparatively lower than product A and B, which is true. So this will lead to decline, or this will result in a lower cost which has been calculated as per the ABC costing for product C as compared to product A and B, because for product C the number of setups are only 8. So I think the second statement holds true. Switching to ABC is unlikely to change Gadget company's decision about product C, as the unit cost saving is only 7.5%. The unit cost saving is only 7.5%. I think this is false, because switching to ABC costing means product C goes for making a loss as per this statement. Okay, so as per this statement, it will be like switching to ABC unlikely to change Gadget company's decision about product C, as the unit cost change is only 7.5%. Now in this statement we can see, as per the traditional absorption costing, product C was making a loss. So from switching to ABC costing, this would definitely result in gain. But is this gain like 7.5%? No, it seems to be very minimal. So I do not feel that this statement is correct, because 7.5%, it is clearly visible that it is not producing 7.5% of savings or gain. So the Gadget company's decision about product C as the unit cost change is 7.5%. No, the unit cost change is 13.42 minus 12.48, and because if as per the traditional costing, the full cost per unit would have been 13.42, and if it jumps into the ABC costing, though it is profitable, and definitely it will jump onto ABC costing method, so the cost will be now 12.48, and this is resulting in saving only. But how much saving are we making? 0.94. So 0.94 upon 13.42, it is making only 7% and not 7.5. So last statement is incorrect. So only second is correct. That means D is the only option. Let's come on to fifth part. Which of the following statement concerning ABC are true? ABC always makes a big difference to overhead allocation. It always makes a big, no, this is not true. It can make or it cannot make. So this is not true. Second, identifying the drivers of cost does not change the fact that fixed costs cannot be controlled, so real savings cannot be made. I think this is also false. So both statements are false, and the question answer is B.